Hello and welcome to another one of my thoughts videos. In this one I want to round up that topic of atoms and sugar and hydrocarbons even, because I'm having to head back to New Zealand, pack up here and maybe even retire, and I don't know if I'm coming back. So I'm not sure exactly what's going to happen to this YouTube channel, whether I'll be able to continue working on it from New Zealand or not. So I just want to tidy this one up and maybe get as much as I can before February. Now, you may not be interested in chemistry and atomic things and stuff like that. So what really does it have to do with the life of your average Joe Blog and all the scams and lies and deception that the worldwide globalist leaders and such like are perpetrating upon us? Well, it does actually. The whole atom thing and sugar and atoms comes down to one of the things that they're trying to manipulate us and control us with is our energy. Now, energy is a very essential part of our life, and it basically comes from the sun, goes through the plants, and all of the hydrocarbons or the fossil fuels that they are trying to curb at the moment to make life uncomfortable for us. There's no need for it, and it ties in and is an extension to the sugars, because the fossil fuels, along with the supposed greenhouse global warming stupidity, and therefore the carbon credit system, is all a bogus setup to basically make our lives uncomfortable and theirs very comfortable. Now, if you've seen the last video I did, you might remember the process by which the plants split the water molecule into its hydrogen and oxygen atoms. And the oxygen that they throw out into the atmosphere for our benefit, and the hydrogens they save for their processes of being a living organism. Now, the next step of that is being able to save that, and I got interested in this whole area due to a series of videos I've done on a generation of electricity, where that electricity is generated and how you can store it. And the plant has found a very simple but incredibly amazing process to do that. Now, remember our little hydrogen atom that came off the water molecule, two hydrogens with the oxygen, with its proton, neutron and an electron, and it accepted an extra electron to free it from the oxygen, and then we have it floating around negatively charged. Now, the plant takes that hydrogen so it can transport the energy that is involved in having that extra electron there. It takes an adenine with a nitrogen and a 3 phosphates, that's triphosphate, and it adds, and that's positively charged, so that when it gets the hydrogen added to it, it becomes stable and balanced. Adenine triphosphate with a hydrogen on it. And that is how the electron is transported around the plant and used in many, many different energy processes by adding and separating that hydrogen. Now, to save that permanently, instead of on a day-to-day basis, when the sun is gone, it needs to store that, and so to store it, it makes a sugar molecule. Now, the storage of that energy is where the bogus carbon, the global warming, there's too much carbon in the air, carbon dioxide, that's a load of rubbish. The plant takes takes 6 carbon dioxides from the atmosphere, because it wants those carbons, and each carbon has 4 spaces that it can share to link things together, and there's one of them. And in the carbon dioxide, here we have one of them. The carbon dioxide, it gets rid of one of the oxygens and uses to bond that as a double bond. It then takes a hydrogen that it has taken from the water and puts that in there. And in each of the carbon dioxides, we have here we have an oxygen there, an oxygen there, one. On each of those, we have an oxygen which is kept from the carbon dioxide, which is 2 oxygens, and it gets rid of them, so that eventually you get 6 oxygens thrown out into the atmosphere. And onto that, those carbons, they are added some hydrogens as well. 2 there, another one, hydrogen. And this is what you call a glucose molecule. That is the sugar molecule. Now the amazing thing is that when people said I was having too much sugar in my coffee because it's bad for you, well, I found out that all 100% of our biological processes and the energy needs of our body is this molecule. There is no other molecule that our body can use to gain energy apart from maybe a protein which is reassembling of this molecule. This is where our energy comes from. Now there are a few other kinds of sugars, but very few. One is lactose, which takes the string of carbons. Now only mammals can do this. Plants do not. It takes the glucose molecule with the oxygen, hydrogen here, OH, H, H0, H, 0H, OH, and in this level here it takes one hydrogen, it basically swaps it from the glucose. If you see in the glucose, that level is an HCOH. Well, it swaps it to HOCH. It swaps the oxygen from one side of the chain to the other, and that's the only difference between lactose, that mammals take a glucose molecule, convert it by doing that to lactose so that they can feed their babies. That is not a bad sugar also. Now there is one more kind of sugar. There's the glucose, lactose, and one called fructose, and this one is sort of the bad sugar, if you want to name a bad sugar. It's a sort of a glucose molecule, but it is an unfinished one. We have the 6 chains of carbon once again, and we have at the bottom, same as glucose there, and an H, OH, and another one that's the same as that one there. But up the top, instead of having that branch at the top of the glucose molecule here with the C with the double OH, it has its double O there and an H here, but it's got some extra H's because the molecule is made in 2 halves, and it's sort of like fructose is an incomplete or a variation on the glucose, and it has that there. This is an L-fructose. Now there is another D-fructose here, which basically just swaps a couple here, so you've got C, 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 and the only difference between those is they're swapped around. Same thing. You've got your double bonded oxygen, hydrogen, oxygen, hydrogen, hydrogen, oxygen, hydrogen here swapped. Then the others also swapped, and this is exactly the same as the glucose molecule there. The only difference, the fructose here, you take those two and swap them round. That's the only difference. But the fructose is virtually the same, and a fructose is basically a glucose which cannot be used by the human body, believe it or not. And this is where we need some clarification. So as you can see, there is really only one kind of sugar that is useful to us, and that's glucose. It can be converted to lactose by mothers who feed their babies, but otherwise it's glucose, and glucose is the only sugar that we can use. Now, the bad sugar, if there is one, is fructose, and fructose is not usable by our body unless it is converted to a glucose molecule. And in fact, it can't even be taken into the body without being paired with a glucose, and I'll explain that just now. And there is a process that is the body, I think it's the liver, can do to convert that fructose into a glucose to make it usable. The process is very much like processing alcohol, so it takes energy and there are some byproducts, or it's difficult. In fact, we use so little fructose and it is so difficult to process that we don't seem to have a monitoring system to judge the levels of fructose in our blood, because it's totally useless unless it is converted to glucose. So our monitoring system does monitor glucose, but it doesn't monitor fructose. Now, all the other kinds of sugars, there's dextrose, maltose, and all the other oses, are merely combinations of the glucose and fructose molecules. The glucose, when the plant makes it, chains them together into long strings of glucose, and they are called starches. And they're often called carbohydrates because they're carbons with their hydrates, the hydrogens and the oxygens. It's basically saying sugar, chains of sugar. Maltose and dextrose. Maltose is when the chain of starch is broken into shorter chains, and dextrose, I think, also has a certain number of glucose molecules in the chain shorter. That's when the plant starts to break the stored starch, say in seeds, to break it back into glucose, into which it can use in its daily processes as well. The way that we process and store those glucose molecules is through glycogen rather than starch molecules. As starch molecules are a long chain, we have one central glycogen point with spirals of glucose coming out that the liver does for us. And also the fructose cannot be ingested by the body. The glucose in the intestine, it just goes straight through the intestine wall into the bloodstream and straight off to the liver to be stored as glycogen and then regulated. The fructose has to be joined to one fructose molecule to a sucrose molecule. Now, sucrose is the white stuff that you put from your table sugar, the white table sugar that you put in your coffee. Sucrose is one molecule of glucose joined with a molecule of fructose. So you have a glucose and a fructose. A banana is very sweet because it has a lot of sucrose. Now, the body can just transport or ingest the glucose readily, and sucrose it is able to also, but there is no mechanism to ingest the fructose on its own. So we have enzymes in our intestine that join the glucose to the fructose to make a sucrose, and then the sucrose can be taken and transported straight to the liver, and then it is split into glucose. Fructose is thrown out into the blood to be processed later, at a later point, and converted to glucose. Now, there is an odd thing that the sweeter the sugar, the less useful it is. Starches aren't that sweet, like bread, cornstarch and things. They're sort of sweet, but not very sweet. Sucrose is sort of sweet, that's why we like to put it in our coffee. But the sweetest is fructose, and that's the odd thing. The sweetest is the least useful to us, but it's what we like the most. Now this is where I do agree with the health freaks who are actually a little skewed most of the time, is that the manufacturers of foods realize that we like sweet things, so they figured out how to manufacture fructose out of the glucose. That means taking cornstarch usually, and by pressurizing and doing things, turned it into fructose, so it is sweeter. So they pile a lot more useless fructose into their products to make them sweeter for us to buy them. They're more readily, we will buy a sweet thing rather than a non-sweet one, so they make them sweeter with the unusable fructose. Now that's like putting alcohol in all your beverages, all of your coffee and milk and everything, so that all the alcoholics who love their alcohol will buy more of that product. By putting more fructose in your product, they're putting a more alcohol-like useless substance to us that we have to process, like we process, similar process to processing alcohol, to be able to convert it to glucose that we can use. So yes, there is one bad sugar which you should tend to avoid, and that is fructose, which is unfortunately what the manufacturers are piling on more and more. So there is a fine line between these health freaks saying sugar is bad for you. That's a load of rot. Sugar is essential for our survival. However, they're right that if you put a lot of fructose in, that is a load on your body that your body does not really need. It is better to go with the starches, the non-sweet things, because they are much easier to ingest and use directly, rather than having to go through the sucrose process, which is not in itself bad, but it has the fructose, which is a lot more difficult to process. But we can still process it just as we can process alcohol. So that was my big roundup of my big findings. No, sugar is not bad for you. Doing 2 teaspoons of sugar in your coffee is way less harmful to you than eating 10 slices of bread, for example. And it's the fructose in it that is the damaging thing. So steer away from the sweetest things like Coca-Cola, for example, bananas even, because bananas are 50% fructose. And a whole bunch of fruits. That's where you find most of your fructose, is in fruits. So strangely enough, by eating fruits, you're eating the bad sugar, and by eating potatoes, rice and things like that, you're eating the good sugar, the readily usable sugar. Now that's sugar, my roundup of sugar. Sugar's not bad for you. Fructose you should tend to avoid, but it also is not going to kill you. Sugar's necessary for your survival. Now, how does this tie into the fuel crisis, the fossil fuels and the global warming and carbon credits scam? Well, the plants take these carbohydrates and they alter them, change them, swap them around with other chemicals and things, or other atoms, to make their structures, like their cellulose and pigments and all sorts of things that they need to survive, and they turn them into hydrocarbons. That's oils and fats and celluloses and all sorts of things. Hydrocarbon means that you've got carbons and hydrogens. The same process as photosynthesis and electrolysis to generate hydrogen and oxygen, separate the water molecule into hydrogen and oxygen, and then adding carbons to it, you create hydrocarbons. When you burn a piece of wood, much of what comes off it and what makes the flame is the disassembly of those hydrocarbons, those assemblies of molecules that the plants have assembled, and this methanol, and what comes out in the smoke that often is not burnt is methanol, butanol, all these sorts of oils, and that is combustible. Syngas is the heating up of organic matter so that those molecules come off into gases, which then can be processed, burnt, or further processed into other things. And that's a whole huge topic on its own, which I am studying as to how to generate those things. And there are fossil fuels are essentially a long period of time of plant material that have converted or joined the hydrogens, the carbons and the oxygens into hydrocarbons within their organic matter, which have collected together into gases and fuels, these fossil fuels. They're only fossil fuels because they're fuels that have been around for a long time. Plants today continue to make these fossil fuels. It's just that they're not fossilized yet. They are there. And so there is a lot of potential in taking the hydrocarbons produced through photosynthesis and like sugar production and then into hydrocarbons and all of that, which can be developed in a renewable and continual way instead of shutting down oil wells. In fact, as I said before in other videos, we should be burning more fossil fuels to liberate more carbon dioxide for the plants to use and therefore for us to use. I can't believe how absurdly 180-degree bout faces these evil systems, evil people, evil things are in trying to make our life as difficult as possible. And the common everyday Joe Blogs is blinded or totally unaware of the science of these things, just like this quarantining scam. Nobody really looked up the actual science and you applied some basic logic to it. So photosynthesis, sugar's good for you, you need it, eat it. Just steer away a little bit from the fructose, very sweet stuff, because they've artificially increased it by putting too much fructose into your food to make it sweet for you. Steer clear away of that, but it's not going to kill you. And then the next step, these processes that plants do to hydrocarbons, burn more fossil fuels and look for other ways of utilizing these hydrocarbon processes that the plants do. Wow, we could have a really good planet, couldn't we, if we were sensible and we didn't have so many evil people in it. So, I'm not sure if I'll be back, maybe I will be. We'll see how we go to New Zealand, and it's been nice sharing these thoughts with you and also my other channels for the benefit of encouraging people, I hope. I'm hoping that when I'm in New Zealand I'll be able to continue, so we'll see. Catch you later.